about the science of physics. I'll be talking about scientific notation and all the basics of physics, for example, conversion and all those stuff. So, what is physics? Physics is the scientific study of matter and energy and how they interact with each other. We can actually see physics all around us, and we encounter physics almost every day, and it's a big part of our life, but we just don't notice it that much. So, some of the problems that physics deals with is temperature, size, motion, position, and many more. Physicists also study specific things, and one of the example is thermodynamics, which is the scientific study of heat and temperature. The second type is optics, and optics is the study of light. Now, the next type is mechanics, and mechanics is the scientific study of motion. Now I'm going to be talking about scientific notations. So our first number is 567000. And when you first encounter a number like this, you put a decimal point at the end of the number and then keep moving it until you reach the first number of, so in that case, our first number is 5. So 1, 2, 3, 4, 5, and we stop here and we put our decimal point right here. So we write the number again and we put the decimal point after the number 5. So we have 5.67, but we don't write the zeros. Instead, we write times 10. And since just now we moved 5 times, we write times 10 to the power of 5. Now note that we have times 10 to the power of 5 because we are going to the left 5 times. In this case, we will have to go to the right, and that will be negative. Okay, now in this number, we will move to until we reach the number 7, because that's the first digit of our number. So we moved 1, 2, 3, 4, 5. But note that we're going to the right, that's why it's going to be negative. So we'll write 7.89 times 10 to the power of negative 5 because we moved to the right 5 times. This is in the case where we have the number and we have to write it into scientific notation. That's different because we have the scientific notation and we have to write a number out of it, and this is opposite from what we did just now. You will see why. But first we have the number 3.86 times 10 to the power of 4, and in this case we are going to the right 4 times instead of going to the left like what we just did just now. But this is different because we have the scientific notation. So we go to the right 4 times. Now again we have another number which is 3.86 times 10 to the power of negative 4. Now if we have negative 4, we go to the left. So we copy the number first, and now we move to the left 4 times. So 1, 2, 3, 4, and then we fill our zeros in. This can get confusing from the fact that they give us a number and we have to set into scientific notation. But just remember that if they give you the scientific notation, then whenever there's a positive number, you go to the right, and whenever there's a negative number, you go to the left. But if you're given the number, then it's the opposite way around. Now we have to convert 5 kilometers to centimeters. So first you start off from the kilometer 1, 2, 3, 4, 5. So you add your zeros according to your movement. So you moved 5 times, so you add 5 zeros. So it becomes 5, 1, 2, 3, 4, 5. And there you go, you got your answer in centimeters. The next thing is 568 grams to kilograms. So grams is in the unit place, and we have to move back 3 times. So when you move back 3 times, you also do the same thing with your number. So you go back 3 times. 1, 2, 3. So you end up with 0.568 kilograms. Now we have 3.8 times 10 to the power of negative 3. So we move it to the left 3 times, so it becomes 0.003a, and this is in seconds still, so now we have to convert it into milliseconds. So how do we do that? So we go to the sec from the units, and then we go to milli, and we're going 3 times to the right, so we do that to the same thing with our number. So we end up with 3.8 milliseconds. Rules of sig figs. So the first rule is all non-zero numbers are sig figs. So all, for example, 19, 8, 3, all of them are non-zero numbers. Anything that is not a zero is basically a sig fig. So for example, 2 has one significant number, 399 has three significant numbers because they're all numbers, not zeros. The second rule is leading zeros are not significant zeros. What do you mean by leading zeros? So 0.00486, 0.0 are leading numbers, and they are not significant. Therefore, we have 486, which are three significant numbers. Number 3, all zeros after a decimal point are significant numbers, which are trailing zeros. So for example, 8.00 has three significant zeros because the 0 and 0 after the decimal point is counted as a significant figure. The same thing happens for 68.0. So now let's do some practice and see how well you can understand. 0.3 has one significant figure. 0.34 has two significant figures. 0.340 has three significant zeros because the 0 comes after the decimal point. 0.3404 has 4, and the last one has 6. 1.5 has two significant figures, but 1.50 has 3. 10 has one significant figure, 100 still has 1, but 10.0 has 3. The rules of adding and subtracting significant figures and multiplying and dividing significant figures. So first let's start with multiplying and dividing. Your answer while multiplying and dividing significant zero figures is the smallest number of the two numbers that you're multiplying with. So for example, 6.38 times 2.1, you will get your answer, which is 13.398, but since the smallest number is 2.1 has only two significant figures, which are 2 and 1, your answer should also have only two significant figures. Therefore, you'll only have 13, which is your answer. Now, for adding and subtracting significant zero figures, it's different because your answer will depend on the decimal places. So the least decimal places of the number you're adding or subtracting with will result with your answer. So 3.06 has two decimal places, and 4.3213 has four decimal places after the number. Therefore, your answer will only have two decimal places, and that's what we did with our answer for 7.38. Accuracy is being close to your target. So it's a state of being correct. And this is a photo of being very close to your target, and that is very accurate. Precision, on the other hand, is when you have closely related numbers but not necessarily close to the target, but the numbers are very close to each other. Errors. So the first type is random errors, are errors that are caused by factors which vary from one measurement to another. Random errors keep on changing. For example, if you weigh yourself the first time, you get +3 of your actual weight, and you do it again and then you get +10 of your actual weight. So it keeps changing from time to time. But the second type is systematic error. And systematic error is when there's a problem with the system, not a problem that keeps on changing, like random errors. So this time, for example, if you weigh yourself, you get plus 10. And no matter how many times you do it, you still get plus 10.